Hello and welcome back. It is time once again to try to fix something. And today on the workbench, I'm working on another Xbox One S. And let's see what it is doing. I think this is a no power or something. It's not a simple HDMI, I'm pretty sure. Let's see what we have. Okay, white light, we're powered on. And we cut off. After, say, 4 seconds or so. Will it turn back on? No. Once she shuts off, that's it. Okay. So that's what we're starting with. A not so fast, on and off. I don't know what this is. We'll find something hopefully when we get inside. Let me get the covers off of it. Oh, and just for completeness, she has been opened. So, yeah. Well, so far she's looking pretty clean. Almost too clean. So I'm not sure what's going on. So maybe it failed and somebody decided if they blew it out it would fix it. I don't know, but it's remarkably clean. Let's get the power supply and hard drive out of the way. Maybe we can see something. Well, that didn't seem to reveal anything. I don't think. Still no signs of liquid damage or flames coming off of anything. Okay. We'll keep digging. Alright, I've got the, of course, hard drive put to the hard drive is out of it totally, actually sitting over here. Blu-ray is still hooked up. And let me see if I can do this with, not sure if I can do this with one hand. I guess I've got to cycle the power on this, which is almost impossible with one hand. Okay. Plug back up. The fan spins for a moment. I think it's kind of normal. And we do have 12 volts. Looks good. And if I turn this on, we come up, the fan spins for a moment, and we stop. Light goes out, and our 12 volts is gone. So our 12 volt supply is shutting down. Where's my test supply? Right there. Let's see if that gets us anywhere. We'll swap that in there. All right, my questionable test supply is hooked up. See if it fares any better than the original one. Okay. No. And our 12 volts is again gone. So we have a short of some kind, don't we? We have a short that's so severe it shuts down that 12 volt supply. And that supply is capable of quite a bit of current. But it's got to be something switched, because if you just plug the supply up, you'll have 12 volts sitting there all day long and it doesn't seem to do anything. It's not really drawing any current. Well, I haven't, not that I can tell. But it'll sit there in standby, no problem. But when you enable it, when you hit the button and other rails come up, then it falls flat on its face. Okay, let's get this board inside and see what's going on. All right, we are inside the workbench. I'm not quite sure where to start here, but I think I'm going to start looking at some power rails. Good as places need to start. Continuity mode. Just see if we can find anything obvious. Problem is, it's not going to be one of the standby rails because 12 volt supply stays up in standby. So it's got to be something that's switched on, at runtime. I'm not entirely sure what rails are switched on at runtime. Although I'm pretty sure these are the supply voltages into the CPU are switched at runtime. Let's see, 41 ohms. I'm just going to look around some of these large inductors right here, or these MOSFETs right here, which, you know, low readings. I just realized I'm actually in resistance mode, not in continuity mode. Got to hit the button. Let's just zero out this meter just to get us a good zero reading. Okay. Because, I mean, these readings in this area are going to be low. 1.4 ohms. This is 1. This is the same thing, I think. Nope, 0.6. 0.6, which sounds really low, but I mean, they are just low. They are low readings. I'm just checking on some large capacitors in this area. One side's ground, you get 0 ohms on that side. We're getting the meg ohms on the other. Oh, that looks fine. What is this? 3 ohms. Okay, that's, I've checked that rail before. I want to say 4 or 5 ohms is pretty common on that. Let me see here. What is this? That's ground. Like I said, this is like a standby. What is this? 3.3 or 5? I think that's 5. That's 3.3, which I don't think the problem is a standby anyway, though. Because if you had a short on the standby, it would be shutting down as soon as you plugged it in. There are several voltage test points on this board. I'm just going around and looking at them. See if any of them have a really low reading. There's a fuse of some type. Reading in the meg ohms on both sides. Yes. 78 ohms there. What about on this RAM? 0 on one side, 40 ohms, 41 ohms on the other. I think that's normal. That looks normal to me. What about around the video chip? The HDMI output chip, I should say. Well, I'm not seeing any shorts. Okay. Maybe time to consult the schematic. Try to figure out where some of the switch supplies are. And since it does stay up for a few seconds, like 4 seconds, it may be enough time for me to actually check a few things if I know what to look for, which I don't at the moment. The thing that's going to pull the most current normally would be this area, the APU V-core area. Nothing's jumping out. I mean, there's some low impedances there, but I think they're just usually low. I mean, it's a processor. It draws a lot of current at 1 volt. Nothing obvious jumping out at me. Absolutely nothing. Reading 1.6 megs on the 12 volt bus itself coming in. 1.5 meg. I don't know. I'll bring you back if I find something worth mentioning. Well, now that I think about it, maybe there is something worth trying here. Since you will stay on for a few seconds, let's try the old thermal cam. How does that sound? All right, we're ready to take a look at this under the thermal cam. I think that's just a big reflection right there. Turn off some of these lights. Does that help? Or is it just a little bit warm? I don't know why that's so warm. Doesn't feel warm. All right, let's see what happens when we hit the power button here. Processor, Southbridge. And we didn't shut off yet. What gives? Then she shut off. Not sure if that was any longer than before or not. All right, let me stick the tiny heatsink on there. And it turned right back on without unplugging that time. Southbridge is getting slightly warm. That's some kind of a regulator there, it looks like, is getting warm, which is probably normal. We're staying on now. The only thing I can think of that's different is I have removed the Blu-ray drive. I removed the hard drive, but I did not remove the Blu-ray drive. You can see her heatsink getting warm. Yep, she's getting toasty, but she's staying on now. You can't see the light in this mode, but the white light is on. She's not shutting off. What gives? Maybe I should go get my hard drive. Well, I went out to get the hard drive. Got that hooked up. Let's see what she does now, if it does anything any different. Let me turn this fan on that processor. So I've got a monitor hooked up over there. And we are turning on. What gives? All I've done is bring the thing in here and unhook the Blu-ray drive. I don't like intermittence. Looks like it's in the middle of a update or something. Hope I can keep it cool long enough to finish what it's trying to do. All right, where are we now? Well, as you saw, it was trying to finish its update, and it everything seemed to go well with that update. It got to a certain point though, and gave me E100, error E100, which is basically means it can't talk to the Blu-ray drive, which was not in it. So I went out to the garage and grabbed the Blu-ray drive and decided I would just kind of hot swap it in there. That was a bad idea, but I did it. Plugged in the data, no problem. Plugged in the power, and everything shut down immediately. Immediate loss of power. So, and then with the Blu-ray installed, we had that same, approximately 4 seconds of white light that then cut off. And I think I figured out why. This is the power going into the Blu-ray drive. And I believe, if I can get zoomed in there, pin 10 and 12. But you can see 12 labeled right there. 10 is right beside it, I believe. I'm not exactly sure on the markings of this thing. But anyway, I've got my meter. Let me zoom back out here on continuity mode right here. And you can see I got my ground. If I go right here to pin 12, dead short. So, yeah, the optical drive is shorting our 12-volt rail. Let's see if I can show you over here on the schematic. But as you can see, it shows pin 10 and 12 are both V_12 P0 underscore optical disk drive, ODD. So it's a switched 12 volts, which is why the standby 12 was not affected. It's not until the south bridge or whatever turns on the optical drive, the power to the optical drive, we get a dead short on our 12-volt rail. So yeah, we're going to have to go inside this optical drive and see if we can figure out why we have 12 volts, why we have a short on our 12-volt rail, and can we fix it? All right, so we know we have a short inside of our Blu-ray drive. And thus far I have not been able to locate it. So, according to the schematic here, pins 7, 9, and 11 all ground, which I believe are on this side of this connector. There's 11, and here's 12. Yep, we are still dead shorted. And I've removed these 2 ribbon cables. One of these going to the laser, and this one's probably going to the some of the spindle motors and that kind of stuff to spin the disc. We still have a short. I haven't seen, I've looked around the board under the microscope. I didn't see anything obvious. So, yeah, we may have to just inject voltage in this. And it's such a dead short, it's not going to take much voltage to be able to. Let me go ahead and warm up my soldering iron, because I think we're going to be tacking some wires onto there. And let's just see what gets hot. If we're lucky, it's just a simple little ceramic bypass capacitor. If we're not lucky, it's a proprietary IC that we can't replace. And I've never really worked on one of these things as far as on this board. I worked on one that had some mechanical issues. And I know, like, if you swap out this drive, you have to swap this board out. The board is married to the main board in the chassis, so they have to travel together. So if you lose whatever chip is on here that has that programming that's married to the main board, you're out of luck. But you can move this chip to another working board if you need to. But I don't know which one of these chips is the one that has the information on it. A quick Google search will probably tell me that, but let's hope that we don't have to go there. Let's see. Let me get my bench supply cranked up here. I'm just going to set this for like a volt, maybe. With this low of a short, we shouldn't have any problem getting all the heat we want. What I'd like to do is not damage something, have something catch on fire or burn a trace or something like that. I just want to see the heat. So let me get a good ground, which I'm not sure if that's is the chassis, the frame tied to this ground. Surely to goodness it is. Like here's the ground pin, pin 11 of that IC, of that connector, I'm sorry. And it's not. Well, is it? Here? Right there. But the outer frame, you know what it is? It's because this thing, this inner piece is just sitting in this outer shell right now with no screws in it. So it would be grounded normally, but because I've taken screws out, it's kind of floating in this shell. But like that's probably ground. Yeah. That little lip right there is probably ground. So I can probably clip right there. Because you want a good ground connection because you want your heat. You want all the resistance to be wherever that short is. You don't want to have extra resistance around the board. You know, that could be dissipating heat that you need to find your short. Okay, let me get that set up, and I'll have to use my phone here with the thermal camera on it. Let's get that set up. Let me just show you where I have connected here. So I've soldered a wire to pin 12 of that connector. And if you can't tell, that's where the DC supply goes in. Pin 12 is 12 volts. And I'm getting a ground right over here by this mount near this motor. And I am set for 1 volt, 1 amp. And if I turn that on, we get a full amp. Yep, pretty dead short. So let's switch to the thermal cam. All right, let's see what's getting hot, shall we? Oh, what's this down here? Is that some reflection, I think? No, that's not a reflection, is it? It's got to be a reflection, yeah. I've got it off right now. I'm trying to figure out what that... That's just a screw. That's the screw head. Okay. 1 amp. It's only 0.3 watts, though. May have to jump it up a little. I'm looking at these ICs and I'm just not seeing it there. Okay. We'll give it a little more current. Okay. Raise the current to 2 amps. Oh, what is this? Oh. Is that a reflection? I don't think that's a reflection. It's one of these ICs here in the corner. 1.5 watts dissipated. That's not the IC. It's a capacitor over here by the IC. Okay. Right in there. There are 2 capacitors side by side. Okay. We'll have to narrow it down between those 2 capacitors. Maybe a little alcohol under the microscope. How's that sound? All right. The area we're looking at is going to be right in there. You see my fingernail? Right there. One of those 2 capacitors, I believe, is shorted. They're just so close together, I couldn't tell which one was which. Okay, let's look under the microscope here. See if we can narrow down. Yeah, it seemed to be one of those two. Okay, let me get a little alcohol on a swab. And all right, supply is back on. The upper one. No, well, both of these went. I don't think they're both shorted, are they? Okay, I would guess this upper one. They're both kind of evaporating rather quickly, though. What if I do that? Just drowned it. All right, that one won the race. C233. C233. It's a suspicious sounding name. Okay. We need to remove that one. I have a pair of hot tweezers here that I never seem to use. But this looks like a good occasion to break them out. Swap out with my micro pencil. It's probably going to scream when I do this. No, it didn't scream. Okay. Maybe some flux. A little bit of flux. I'm going to add a little bit of leaded solder to each side there. Let's see if she'll come off willingly. That is a big capacitor. These hot tweezers just do not have a lot of thermal capability. It doesn't help that this is mounted to some large buses down there. All right, that's just not happening. Thank you for your valiant effort there, little tweezers. But you are of no further use to me. So let's try this another way. How about a little bit of low melt solder on either side? Take my tweezers. There we go. Extracted. Make sure I don't have any shorts in here. All right. Let's see. Let me move the microscope out of the way. Is our short gone? Is our short gone? So if I go from pin 11 to pin 12. Oh yeah, she's gone. Okay, yeah, we're up 1,000 ohms. Okay. And I should be able to apply this. Turn the power supply on. Yeah, 1 volt, she draws 2 milliamps. So that little capacitor, which I may have lost already, I think I laid it off here to the left. Where did it go? There it is. There it is. That, which looked perfectly normal and healthy, is our issue. I mean, there was no visible crack in it that I could see. Maybe we'll take another look at it under the microscope. I'm just curious. Let's just look over here. A little dirty. I'll see if I can get some focus. There it is. Oh, well, there I do see a crack. Yep, that must have been on the bottom side of it. Because I don't think that was visible from the top. See those little lines? Sorry, I'm trying to get it in focus. There you go, there's a good shot of it. It's subtle, but it's pretty obvious there. I think it was on the bottom, though. So I have no idea the value of that capacitor. Now what I may do is take out the one beside it and check it, because they're probably the same size. Let me see if I can do that. Alright, I believe our Blu-ray is repaired, and I've got it reassembled. The capacitor I took off and checked, the one right beside that was bad, was a 10 microfarad. So I believe the other one was a 10 microfarad as well. So I replaced it with a 10 microfarad. And, confirmed again my short was still gone, and it was. So we're ready to see if this thing will do something. Well, except I forgot to... I believe this is the Wi-Fi module, or one of the Wi-Fi modules, I'm not sure. Let's put the front panel board on, which I can't see. There we are. All right, thought I was ready, but I wasn't. Turn our fan on. AC power is on. Yep. I have a monitor connected. Let's see what she does. She's staying on, and the Blu-ray is connected, so that's an improvement. Are we going to get a picture? Yes, we're still in the middle of our update. And, of course, it failed out earlier because it could not find the Blu-ray. Because I had removed it, which is what allowed it to actually start up, because the Blu-ray was shorted. The 12-volt line was shorted. So let me see if this will complete this update, which is going to take a minute, and I'll bring you back. This looks good, though. Finally, I think we're through with all of our updates. And now it wants us to sign in. Okay, so that looks good. Let me get this put back together, and we'll take a look at it out in the garage. All right, we are back out in the garage. Our Xbox One S is fully reassembled. I did a little cleanup on it. It was really not that bad, just a little bit of dust. That's about it. But otherwise, she's cleaned up and ready to go. Let's see what she does. Does it have a disc in the drive? Alrighty, that looks good. Yeah, I hear a disc in the drive. I gotta see what kind of bonus disc we got. Call of Duty Black Ops 3. That's the second one of those I've gotten. I never even noticed there was a disc in it, even though I was in the Blu-ray drive working. I just didn't notice it. But I think this one's going to be good to go. She should be updated now and ready to roll. Well, anyway, I hope that one was somewhat interesting or educational. If it was, please give me a thumbs up, and I will see you in the very next repair. So long for now.